Okay, in this lesson now, we are going to look at taking all four trig functions and adding some shifting to them, some left-right shifting and some up-down shifting, okay? So first of all, I just kind of want to remind you of what happens. This is a basic sine function, the parent sine function. You can see it crosses the x-axis at 0 and pi and tops out and bottoms out, normally goes up first, all of that good stuff. So this is the normal sine function. If we add that plus 1 to the end, what that's going to do, remember, is to shift that whole entire graph up 1. So now instead of our midline right being at 0 right here, our midline now is at 1. Okay? And when we graph these, we're going to cheat a little bit, and we're going to just relabel our midline instead of labeling this spot right here as 0. If we were graphing the red function, we would label this spot right here as 1. Okay? And that's what we're going to do when we graph these. And obviously, if it's down 1/2, then your midline becomes negative 1/2, and this now is your midline. Okay? Excuse me one second here. All right, so now we're going to look at what happens when we add on something inside that parentheses like we did here. And by the way, you guys, when you're doing your homework today, I like to have 2 different colors when I do this. And so if you want to hit pause and grab maybe a pen or so you have a pen and a pencil or different colored markers or whatever you have, that might be helpful when you're doing these notes. If not, that's fine. You can use dotted lines and solid lines or whatever. But anyways, this now is when we've added on something or subtracted something inside the parentheses. So notice we have this plus pi over 4 right here. And what that did in the red line is it moved that whole entire curve, pi over 4, to the left. So when it's a positive in here, it actually moves it to the left. When it's a negative in here, it moves it to the right. And if your period is different besides, that will change how much it moves left or right as well, and we'll talk about that when I do some more examples. But when you add something on inside the parentheses, it does move it left or right. And here it was negative pi over 4 that we put on there, and it moved it to the right, pi over 4. And so on this one, what this did is it moved it right pi over 2 and up 3/4. So it changed my midline to 3/4. It moved the whole graph right pi over 2. And again, how much it moves left or right will also be affected by what's here, and you'll see that in a minute. All right, so we are going to graph a couple of these so that you can see what happens here. And we will work through this as we go, okay? So, first of all, I do not have any even and odd properties that I need to worry about because there's nothing added on right here, or no negatives, I mean, right there, so I don't need to worry about that. So I'm going to kind of go through my list, and now we're going to add on the left-right shift piece to this. Okay, so here we go. First of all, on my list, there is a negative out in front, so it is flipped. My amplitude is 4. My midline comes from what's at the end back here, so my midline is negative 2. This is a cosine curve. Cosine is normally has a period of 2 pi, and so in this case, to recalculate my period, I'm sorry. Okay, so our period, again, cosine is normally 2 pi, so I will go 2 pi over the number in front of the x, which is 3 pi over 4. Okay, so instead of dividing by 3 pi over 4, I can multiply by its reciprocal. The pi's will cancel out, and I will get 8 pi, or 8/3. Okay, so that will be my period in this case. Then your phase shift, or your left-right shift, your horizontal shift, will actually be what's back here over this. Okay, so this over this, your phi it's called, over your w. Okay, your phi is this little symbol, and then this is your w. Okay, so your phi over your w is your horizontal shift, and so the other thing is, because this is a plus right here, it will go to the left, and so it will go to the left pi over 3 pi over 4. Okay, and again, instead of dividing by 3 pi over 4, I can multiply by its reciprocal. The pi's cancel out, and I get 4/3. Okay, so that's how that will work. And so here we go. I'm going to graph this first of all without the left-right shift in it. So I'm going to do this the first time without that. Okay, cosine normally has a period of 2 pi, which means I need 4 quadrants to it. And so I'm going to make 4 quadrants for this cosine curve. The period is 8/3, so this will be 8/3 right here. If I cut that in half, I get 8/6, which reduces to 4/3. If I cut that in half, I get 4/6, or 2/3. So 2/3, 4/3, this would be 6/3, and 6/3 reduces to 2. Okay, and I'm going to label some more in a minute here, but we're going to start right there. My midline is -2, so instead of this point being 0 right now, I'm going to cheat and relabel this point right here as -2. What that really is doing is shifting the graph down 2, so the center of my curve, instead of being at 0 now, is at -2. Then my amplitude, if I remember correctly, was 4, so I'm going to go 4 up from -2, and if I go 4 up from -2, I'm at +2. And if I go 4 down from -2, I will be at -6. Okay, now I want you to draw this curve just very, very lightly, or I'm going to draw mine dotted so that, because I can't draw lightly on the smartboard, but I'm going to draw it dotted. Okay, this is a cosine curve, and cosine normally starts up high, but since this is flipped, it will start down here. So it will look something like this. Just draw this very lightly. This is without the shift in it now. Okay, so this is what it would look like before it gets shifted left or right. So these are some key points right here. Here, 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 and here are kind of my key points. Okay? Now, that graph is going to get shifted 4/3 to the left. And if you look right here, 4/3, if you measure that from 0, is 2 hash marks. Okay? So this whole entire curve is going to shift 2 hash marks to the left. I'm going to move the black curve 2 hash marks to the left, and that's where my new curve is going to be. Now, I need to have some spots labeled if I need to move this. So this spot right here would be -2/3, and just following, it's the opposite of this. This is -2/3, this is +4/3, so this would be -4/3. Okay? So everything again is going to move 2 hash marks to the left. So this spot right here is going to move 2 hash marks to the left and become here. This one is going to move 2 hash marks to the left and become here. Okay, and you're going to continue that pattern, and the whole curve is going to be moved 2 hash marks to the left. You know what? I don't think I did that right, did I? Did I move that 2 hash marks to the left? Yes, I did. Okay, so there you go. 2 hash marks to the left. Everything is going to go 2 hash marks to the left, and it will be shifted like that. Okay, and I actually put some extra on here. I really and truly don't need this piece right here, but that's what would happen if I would continue doing that. Okay, so that curve got shifted to the left. Now, when you're doing your homework, you guys, I really and truly don't need what is my black dotted line in there. I don't need that. If you can go right to this without having to do it in 2 steps, that is fabulous. Go for it. Okay, some of you can. I'm going to do it in 2 steps so that you can kind of see what happens, but you can do yours in 1, and that's fine. I do not need the black dotted on there. If it is not, but one thing I do need though is I need you to make it clear which one is your final graph and which one is your not your original. Okay, so like to me, this, I would assume that my solid line in this case is my final graph. So if you do something different, just make sure you label that for me. All right, here's a tangent one. Okay, and so we're going to follow kind of the same protocol here. I do not need to worry about any even and odd properties, so that is good. So I'm just going to follow my little list that I go through. I don't know why I just wrote y equals, but here we go. There is no negative out in front, so it is not flipped. Okay, my amplitude is 2 because of that number out in front. My midline, because of the 2 that's added on at the end, the +2 at the end, my midline is also 2. Okay, this is a tangent curve, so be careful. Remember, tangent's normal period is pi, so when you figure out your new period, you're only going to go pi over the number in front of the x. So pi over 4 pi becomes 1/4. And then your phase shift, again, this is a plus right here. And so because it's a plus, it is going to go left. If it was a minus, it would go right. And it will go left this number over this number, okay? Every single time. So it will go left pi over 4 over 4 pi. And again, instead of dividing by 4 pi, I am going to multiply by the reciprocal. The pi's will cancel, and I will get 1/16. So it is going to go to the left 1/16. Now, when you make your tangent graph, remember, there's something different about that. Tangent's normal period is pi, so when you make your graph, you only need to make 2 quadrants instead of 4. Okay, so 2 quadrants. My period here is 1/4. Yes, my period is 1/4. Okay, half of that will be 1/8. And I'm going to make another one over here for -1/8. In this case, my midline was 2, remember? So I'm going to call this spot right here 2 instead of 0. My amplitude, although it doesn't really matter for tangent, my amplitude was also 2. So if I go 2 up from 2, I will be at 4. And if I go 2 down 2, I will be at 2 down from 2, I get 0. Okay. Now I'm going to draw this dotted and light. Okay. But normally, if you follow tangent's normal pattern, I would have an asymptote right here, and I would have an asymptote right here, and my curve would cross right here. And I'm just going to draw mine small here, and I actually am going to draw that dotted. I meant to draw that dotted. So my curve would cross right there. Okay? And it is not flipped, so that's what it would look like normally. Now, however, I need to take it and I need to shift it 1/16 to the left. Okay, the problem is if you look at your x-axis, I have nothing labeled in terms of 16ths. But 1/16 does happen to 1/16 does happen to be 1/2 of 1/8. So I'm going to need to add some labels in here. 1/16 is 1/2 of 1/8. So I have 1/16, 2/16. This would be 3/16 right here. Okay, and I'm going to label over here as well. This would be -1/16, -1/8, -3/16, and I could keep going, -1/4, and keep labeling if I needed to. Okay, but now if I look at this, 1/16, if you look at it from 0, 1/16 is this distance right here, which is 1 hash mark. So I'm going to take that whole black curve and I'm going to move it 1 hash mark to the left, 1/16 to the left. So this asymptote will now become here. And this asymptote will now become here. And where it crosses the curve right here will now be here instead. Okay? So what I care about is the final product, or the green part of the graph. I really don't care about the black dotted part. I care about the green part. So if you don't want to put the black dotted part on your graph, that's totally fine. If you can do it in one step, that's great. And we are going to do one more, which is a cosecant curve. And then we'll go from there. Okay? Now, cosecant does have this negative right here. And the common mistake people make is they just want to take the negative and they want to pull it out. But what you need to think about is you need to pull that negative out of the whole entire parentheses. You can't just pull it out of the number in front of the x. So what you need to think about before you pull it out is thinking about this, factoring it out of this quantity first. So if I factor it out of there, then I'll have 1/8 x plus 3 pi over 2. Okay, so I need to factor it out of the whole entire parentheses, and it would look something like this. Again, if you distribute this, negative times 1/8 x, negative 1 times 1/8 x would be negative 1/8 x. Negative times 3 pi over 2 would be negative 3 pi over 2. So that's what it would look like factored. Now you can worry about even and odd properties and how you pull it out in front. Okay, if it was an even function, you could just cross that negative out now. But it's not. It's an odd function, so this negative needs to go out in front, and then it will end up looking like this. Okay, so now if we go through our handy-dandy little list, negative out in front, so it is flipped. The 2 in the front makes my amplitude 2. I added that plus 1 to the end of this equation, so my midline is 1. And then my period, this is cosecant, so cosecant's normal period is 2 pi, so in this case I will go 2 pi over 1/8, and instead of dividing by 1/8, I'm going to multiply by 8 over 1, and so my period is 16 pi. And then my phase shift, again, this is a plus right here, which means it's going to go left. If it was negative, it would go right. But it is a plus, so it is going to go left. And again, it'll be this quantity over this quantity. So 3 pi over 2 over 1/8. Okay, so instead of dividing by 1/8, I can multiply by 8 over 1. And then the 2 and the 8 reduce, and you will get 12 pi right here. Okay? So here we go. I'm going to label my curve now. My period is 16 pi. Cosecant's normal period is 2 pi, which of course is 4 quadrants on the unit circle. So period of 16 pi. Half of that, of course, is 8 pi. Half of that is 4 pi. So 4 pi, 8 pi, 12 pi. My midline was 1. And then I'm going to go up 2 from that. So 1 plus 2 is 3. 1 minus 2 is -1. Okay. Cosecant normally has an asymptote, if you follow the pattern, normally has an asymptote right here at the origin. I know this is kind of a mumble-jumble mess right now, but normally has an asymptote here, an up curve, an asymptote, a down curve, and an asymptote. Now this one is flipped, so my curves will be the opposite, but my asymptotes will still be in the same spot until I shift it left and right. So normally I would have an asymptote right here. I'm going to make this dotted and really light. I would have an asymptote right here, and I would have an asymptote right here. Okay, this is flipped, so this would be a down curve right here and an up curve right here. Okay, now all of that's going to change though, because I'm going to shift this curve 12 pi, and in this case to the left. Okay, now if you measure 12 pi from 0, 12 pi is 1, 2, 3 hash marks. So I need to take everything and shift it 3 hash marks to the left. Okay, and if I shift it 3 hash marks to the left, that means I need to relabel some things. So this is -4 pi, -8 pi. Oops, I don't know why I put my pi in the denominator. And then my -12 pi is going to run off the graph, but it'll be over there. Okay, so this asymptote right here will end up going 3 hash marks to the left, 1, 2, 3, and I will have an asymptote at -12 pi. My down curve will go 1, 2, 3 hash marks to the left and be right here. This asymptote will go 1, 2, 3 hash marks to the left and be here. Not real straight, sorry. Okay, this asymptote will go 1, 2, 3 hash marks to the left and be right there. Okay, and then I need my up curve in there, which will be, of course, halfway between your two asymptotes. And there is your cosecant curve that has been shifted. And again, I only need the red. I do not need the black in there, but if it helps you to do the black first and then the red, go for it. Okay, if you don't need to, that's fabulous too. All right, that should do it.